For this short lesson, we're going to look at the essential behavior of logarithms. Let's begin with a very simple rule. The logarithm, any base of any two things multiplied, A times B, can be separated as the logarithm base B of the first factor. You call these factors, remember, when you turn things into multiplication, of the first factor added, notice the plus sign, to the logarithm, same base, of the second term. These b's are not the same. Don't get confused by that. I'm writing it that way because you're going to see it that way, and I want you used to it. So, very simple rule. The logarithm of a product, you should know that word, it means multiplication. The logarithm of a product can be separated into the logarithm of the first factor added to the logarithm of the second factor. It actually can be written in either order. It makes no difference. Okay? What does that mean to you? It means that the logarithm, base B, any base, of a number like 6, can be rewritten as the logarithm, base B, of 3, added to the logarithm, base B, of 2. Why? Because 6 is 2 times 3, or 3 times 2. So I've separated the product into a sum. I know that looks weird. We'll see in a separate lesson where that comes from. But what you're trying to do right now is an intuition for separating the quantity inside a logarithm, if it's multiplied, into a sum. And that's what you want to recognize. So that's rule 1. That's the rule, that's the example. What you want to do is memorize the behavior. Now let's look at rule 2. Rule 2 says that if you have the logarithm, any base, of a quotient, I'll use different letters this time, C over D, that can be separated into the logarithm, base B, of the numerator, that has to be first, minus the logarithm, same base, of the denominator. Some of you probably already had the intuition that that would be the case. Be nice if you did. Start learning to trust your intuition, testing it to see if it's right, but intuition is where things begin for most mathematicians. Let's see this in action. The logarithm, let's say base 7 of 9 over 13. You can separate this quotient into the logarithm base 7 of 9 minus the logarithm base 7 of 13. And there you are. There are 3 rules, and this are the first 2. Let's look at the third rule. The third rule is that if you have a logarithm, any base, there we go again, of a quantity to some power, and I'm going to write that as a small r, kind of traditional, that can be rewritten as r times the logarithm base B of A of this. Now right here I want to pause. This rule is different from the other 2 rules. The other 2 rules produce logarithms around both the A and the B. logarithms around both the c and the d. This one only keeps one logarithm. The r moves to the front, but stays r. Let's see that in action. The logarithm base 10, invisible 10, of 3 to the 12th power equals 12 times the logarithm of 3. All of this is called separation. We're taking a quantity inside the argument of a logarithm. Remember, the word argument is a powerful and important word, and all it means is the quantity of the contents of a quantity. It means the a times b, it means the 6, the c over d, the 9 over 13. That's the argument. So, let's move on and see this working. Suppose you have an equation that you worked, and when you're done, you have x is equal to the logarithm of 4y. And your teacher wants you to have this in expanded form. Expanded, separated, you might hear either word used. Keep the x on the left side, it has nothing to do with the x. You keep the equal sign. Simplifying works down. Remember, there's something on the other side that has nothing to do with the process. Okay, so simplifying, this form of simplifying is called expanding or separating. More words than we need because it's a very simple one step. Logarithm of 4 plus logarithm of 5, and we're done. That simple? That simple. Let's look at it again. Y equals the logarithm base 2 of 9x. Separated, we get log base 2 of 9 plus log base 2 of x. Let's do another problem. Z equals logarithm base 3 of, I'm tired of x and y, let's use w to the 5th power. To separate that, you take the 5 and you write it in front of the logarithm function. Nothing else changes. You can have a parentheses or not, your choice, and you're done. That's all that is involved. Let's look at a combination. Suppose we have a equals logarithm base 2 of 5z to the 7th power. A look ugly problem. How do we do it? Well, inside the argument, let me draw the parentheses for emphasis. Inside the argument, we have a multiplication. 5 times z to the 7th. If you have to pick one letter to describe the process, and we've discussed this before, what we're looking at is a multiplication. The exponent is only part of the multiplication. It's 5 times z to the 7th. Since we have a multiplication, write down the a, write down the equal sign. They have nothing to do with this. We have logarithm base 2 of the 5 plus separating a multiplication, a product, into this. Are we done? Nah. Your teacher gave you a problem that was more difficult. How much more difficult? This much more difficult. Not very much more difficult at all. Look at this. We now have a power in the argument. Okay? We know how to do powers. Do you remember? To expand the power, we take the 7, drop it in front of the logarithm, and we're finished. As easy as that. I think we need some more quick examples, and then we'll be done. Suppose you have a logarithm base 7 of 3, and it's added to the same base logarithm, logarithm base 7 of 7. Let's not do 7. How about 8? And your teacher says to you, combine them. It's the new word now. Combine. What it means is it wants it back in one logarithm. saw the rule for that. If you have the logarithm of two things multiplied, it separates into two things added. If you want to go backwards, if you have the logarithm of two things added, you put them back in here and you multiply them. Go back to the beginning. Then you get logarithm base 7 of 24. Okay? You're saying, what happens if I have a subtraction? And if you're not saying that, you should be. So we have logarithm base 9 of x minus logarithm base 9 of 6. Subtraction means that you started with a ratio or quotient. The numerator is the positive logarithm. The denominator is the subtracted or negative logarithm, and you're finished. You have combined the two logarithms. Opposite of separating, same rule. Separating a product gives you addition. Combining addition gives you a product. Let's look at another example. Logarithm base 10, invisible logarithm of 12 multiplied by x. What's the rule? I want to bring the x into the logarithm. If it's multiplying, I bring it in as a power. Logarithm of 12 to the x power. That is combining. Perhaps we need some more. Okay, suppose you have a problem that you worked out. You got y is equal to the logarithm of 2, it's a base 10, plus the logarithm of a 14. And the teacher says to you, or the book says to you, combine the logarithms, or they say write as one logarithm. And you want to go y equals, that has nothing to do with the problem, don't worry about the y, don't worry about the equals. What you want to do is combine the same base, both base 10, they're added, so you go 2 times 4 and you get 28, and you are finished. Suppose you have n equal logarithm base 3 of x plus logarithm base 3 of 2x minus 1. It's a look ugly problem. Don't worry about it. The m has nothing to do with it. The equal sign has nothing to do with it. Keep them as they are. You want to combine logarithm base 3. You're adding. So inside one logarithm, inside the same logarithm, we use brackets here, you multiply x times 2x minus 1. You can stop right here. You have done what you've been told to do and combine the two logarithms. Now, if your teacher says simplify, then you better go ahead and distribute that x. And if your teacher says you don't need to, then you don't need to. You've completed the work. If you're taking an AP exam in mathematics, you will find that this is a finished problem. Unless you have been specified, it has been specified that you need to go on. Otherwise, you're finished. Another example. Z equals 5 logarithm base 2 of x minus 1. This is a really simple problem. Z equals, keep the logarithm base 2. You want to bring the 5 into it. It's a product here, it's multiplying it. It becomes x minus 1 to the 5th power. I am certain almost no teacher you have will want you to simplify this. This form is sufficient. I hope this has helped. You might want to read through this again or watch through this again and try some practice problems on your own from your book. Thank you very much.